right, hello everyone. My name is Jared, and welcome back to the Virtual R Workshop series. This is the fifth virtual workshop, and today we will be looking at R programming. So let's first take a look at our learning outcomes. So after taking this workshop, participants should be able to do the following: describe good coding practice, use the various types of logical operators, use for loops in conjunctions with other statements like if-else, create your own R functions, use a family of apply loop functions to simplify repeated tasks, and finally, be familiar with some built-in R functions. So as today is mainly about programming, I want to talk about some of the philosophies of programming or best practices. So one of the questions you should ask whenever you are programming anything, you should ask yourself, what are you trying to accomplish with your code? So ask yourself that question at the beginning of when you're programming, and even for each little block of code or each line you're writing, kind of try to ask yourself, what are you trying to accomplish here? That kind of helps make sure you keep on track with your programming goal. So on to some best practices. You want to write code that is going to be readable by both the reader and writer. So code isn't always going to be just read by you. In a workplace, you will probably be sharing code. So you want to make sure other people can really understand what is going on in your program. So you can accomplish this by documenting your code with a lot of comments, meaningful comments that kind of describe what you're doing. And you also want to adhere to the styling conventions of whatever language you are working in. So for R, there are some styling conventions. There is a link that should be in the chat right now. It's a webpage created by Hadley Wickham, who is a major creator in the R space, and he goes over some of these styling conventions for R. Next, you want to write clear and concise code, but also try to avoid complex and short code. So you want your code to be able to be understood, and you don't want it to be too overly short and or too overly long. So you don't want to have like 10 lines of code when it could be accomplished in one. But you also don't want to have a massive line of code that is just pretty much impossible to understand. In some programming languages, you can write an entire game on a single line of code, but that is going to be a nightmare to troubleshoot and to have anybody else really understand it. Next, you want to write code that is reusable. So a lot of the problems in programming come up over and over again. So if you've already written some code that will solve this problem, just find it again and reuse it. So the more often you are writing reusable code, the higher chances are you will have you already have a solution to a problem that you come across again. And finally, you really want to use the tools that are provided to you. So in R and RStudio, we have pipes, which are a great way to logically lay out kind of your steps you are performing on some data. RStudio has automatic formatting, which is great, and it'll kind of adhere to some of those R styling conventions. Loops are very nice when you have a lot of repeated lines of code that you need to do. So you can run those through some loops, which we will look at today. And finally, functions. So let's say you have a big block of code and you are constantly going back to that big block of code and running it. You can actually turn that into a function, and where you can just call a short little function and have that block of code run. So we use functions to kind of avoid copying and pasting the same block of code all over your document. All right, let's jump into R and RStudio, and we can get to programming. So I'm going to start up my RStudio here. And we can actually create our new project. So let me actually make this bigger for everybody. There we go. All right, so I'm going to go in the upper right-hand corner, click Project, and then New Project. And since it's a new directory, I'll click New Directory and New Project. And I'm just going to create it on my desktop. And I'm going to call it R Workshop 5. You can name it whatever you would like. We'll create the project. Once you see this .r project file in the bottom right-hand corner, you're doing good. We can click File, New File, and R script. So we can create our R script. I always like to type something and then save it. So we can save our script because we don't want to lose our work. And I'm just going to call this script. And save it. And now if we look in the bottom right-hand corner, we should have our .r project file and our .r script file. So we are ready to get going. So first up is going to be logical operators. So logical operators are considered, they're just logical tests, and they will return either a Boolean true or false value. I think it's easiest to just demonstrate here. So let's talk about the equals operator first. So the equals operator is actually just two equal signs next to each other. So what's going to happen here is we are checking if 5 is equal to 5. So let's actually run this line of code by hitting Control and Enter at the same time. And you can see in our console, 5 is equal to 5. We think it's true, and R also thinks it's true, which is great. So if you instead passed in 2 equals 5 and ran that, notice it says false. With most of these logical operators, you can kind of test these conditions in your head before you even run the program, just to make sure it's working correctly. So we don't just need to pass in numbers, we can also pass in text. So we can check if Jarrod is cool. So I think we know what's going to happen here. These are not the same text, or not the same strings. So R is going to return false here, which is expected. If we instead put the identical strings, it would return true. All right. With equals to, there is also a not equals to operator. So if I were to check if 2 is not equal to 3, so this not operator is this exclamation point and then our equals sign. So all of this together is not equals. So 2 is not equal to 3. I'd say that's true, so we can run it. And R agrees with us, which is fantastic. So what all of these logical operators are really doing is comparing the left and right inputs and just performing whatever operator we give it. So we can move on to less than. So how about we check, is 5 less than 9? I think it is. Let's run it and check. And it says true, so that's great. So there's the less than operator. There's also the less than or equals to operator. So let's see if 5 is less than or equal to 5. I say it is because, again, it's equals, 5 equals 5. So we run this, and it says true. So again, it's just comparing that left and right input. There is also greater than. It would work just how you expect. So 5 is greater than 9, that's false, and that agrees with me. All right, so those are the main comparison operators we have. There are also some other operators such as and, or not. So we can talk about and right now. So and requires both the left and right-hand side to be true to return a true value. And the AND operator is just the single ampersand. So if I pass into it true and true, it will return true. It will only return false when one of these is false. So for the AND operator, both left and right side needs to be true for the entire condition to be true. There is also the OR operator. That only needs one side to be true. So if I were to put true or false, it should return true because the left-hand side is true. And finally, there is the NOT operator, which will essentially return the opposite of whatever Boolean value is passed into it. So the NOT operator, again, is the explanation point. So if I were to put in not true, it should return false, which it does. So it is essentially the opposite of whatever Boolean value you pass into it. So I want to demonstrate really quick with AND just how like a normal logical operator would work. So let's say we need, we can check if 5 is less than 9 and 9 is less than 10. So how this operator will work, it's going to look at the left-hand side, evaluate this. So it's going to check, is 5 less than 9? That is true. And now it's going to look at the right-hand side, check if 9 is less than 10. That is also true. So it sees true on the left, true on the right. So we should get a true for the entire line, which we do. We'll use some of these later on as well. All right. So these logical operators are going to be necessary for control structures. So control structures, they allow you to really control the flow of a program. They are widely used in like application-based programming, but they do have their uses in R as well. So let's talk about those right now. So first up is the if and if else control structure. And that allows you to perform different actions just based on different conditions. The for loop will actually allow you to repeat an action for a defined amount of times. So when you know how long a loop is going to run, you will run the for loop. The while loop allows you to repeat an action an unknown amount of times. So if you don't know how many times you kind of need to run through a loop, you can use while. So everything below this black bar are generally best to be avoided because when we are dealing with loops, we really want to avoid infinite loops. And like the repeat function will actually just repeat a code block infinitely, and you can only stop it with the break command. So infinite loops, they essentially mean that R is frozen and it is just repeating that loop forever, and you will kind of need to stop the loop manually for your code to progress. So you really don't want that to happen. The next control structure, it kind of absorbs a certain amount of individual loops or iterations. This can mainly be avoided with good programming of the for loop, so you can avoid those next control structures. And finally, we have break, which will just absolutely stop the loop dead. These can also be avoided if you kind of program your if else and for loops correctly or in a more eloquent way. All right, so let's jump back to R and RStudio, and let's actually program some of these control structures and demonstrate them. So let's first talk about if and if else statements. So we, again, let's ask ourselves the question, what is the goal of our code that we're going to write? So let's write a password checking little application here. So I want to create a password variable, and that can just be dog. And I want to create a user input variable. And let's say the user got the password correct. So we'll type in dog. So what we can do is create our if statement. RStudio is very nice about this. If you type in if and then hit the tab key, you should notice this little window pop up. And if you highlight over if and then the curly bracket snippet and hit the tab key again, RStudio will actually generate all of the syntax you need for this control statement. So that is really, really nice. So you can see it's asking for a condition here. So now we need to provide it a condition using those logical operators. So let's check if password is equal to user input. All right. So we're checking if password is equal to user input. And if this is true, then we're going to do whatever in these brackets here. So if they got the password correct, let's just print out that they got the password correct. So now, if you either set your cursor at the bottom bracket or at the top near the if, and then hit Control and Enter, it will run the entire loop. We never created these variables, so let's assign those. I'll highlight them and hit Control and Enter. And in the upper right-hand corner, we now have our variables, and now our loop will run. So we run our loop, and notice we get an output, which is correct. So they got the password correct. But what if they got the password incorrect? So let's say they put a few too many G's. When we rerun this if statement, we get no output because we never are checking if the password is incorrect. So the way we can deal with this is by typing in else and then another if statement. If you hit tab 2 times, it should automatically generate. And now it's going to ask for another condition. So let's provide it that condition where the password is incorrect. So if the password is not equal to user input, we will do whatever is in these brackets. So since the password is incorrect, we can just print incorrect. And now we can run this whole statement. And notice we get an incorrect output, which is what is expected because they gave us the wrong password. So far, the kind of flow for this control structure is if the password is the same as user input, we will print out correct. Otherwise, if the password is not equal to user input, we will print out incorrect. But what happens if if neither of these two conditions are met? We kind of want to know if that happens, so we can actually add a final else statement at the very end and use brackets again. So if none of these other if statements up here run, then it will branch to this else code block and run whatever is here. So let's print that there was an error. Because realistically, there's only two options. Their password can only be correct or incorrect. So if we ever get here, it should be an error. So we can run this, and it is incorrect because the password is incorrect. And now you can manipulate these variables as much as you would like, and you have a great little if statement that will check if a password matches or not. All right. So as you can see, those if statements are really great for just checking if conditions are met, and then you can kind of run a certain command or code block depending on those conditions. Up next is going to be a for loop. So let's jump down here a little bit. And for loops, they kind of allow you to iterate or loop through data or whatever you specify a certain amount of times. So let's actually create a weekly sales variable here, and or a vector, and we'll use the combine function, and let's just put 7 random numbers that could be sales for, I don't know, a small coffee shop maybe. Why not? Let's make sure we get we have 7 of these. So we can run this. Let's make this a little bigger for everybody. There we go. So we now have this weekly sales variable, and it has 7 elements. So that's great. So a for loop actually has 3 different parts or components. First, we need to specify our output. So again, that's kind of asking our question, what do we want to accomplish with this little piece of code? So I actually want to find the sum of all of these sales. So I will first create my sum variable. We want to create that outside of the loop, as it can be a performance hit if we create it inside of the loop. So I'll create my sum variable and just run that. And now I can create my for loop. So if you type in for and then hit tab, you should get this snippet for pop up. If you hit tab one more time, all of the syntax should pop up for you. This is, of course, if you're using RStudio. So you can kind of see here, it's asking for the variable in the vector. So our variable here, you kind of need to look at your data and think about what we're working with. So we're working with weekly sales. So our variable, or the one individual element of that, will just be a singular sale. So like the sale for the day. And it's going to ask for in the vector. The vector is just the data we want to look for or look through, which is, in our case, weekly sales. So now we have our for statement. We need to actually program our logic. So what's going to happen? So when you're dealing with loops, I find the print function and printing kind of what you're iterating through or looping through is really nice for debugging. So we'll do that here. So we can print the sale, the day sale, and let's actually add it to our sum. So we'll have sum is equal to sum plus the sale of the day. So now, and if we actually type sum down here, when we run the entire block, it will output sum at the very end. So let's run this and verify it's working. All right, so you can see that our print is being ran, which is great. And we can actually see all of the sales in our vector. And finally, let's run sum so we can see what the sum is. It is 551. That sounds reasonable to me. But yeah, we can relook at our loop. So again, it's just looking in the weekly sales data or vector, and it is going through accessing each individual element and then doing some work to it. So the work that's done is again in these brackets. All right, so let's combine both ideas because you can nest loops and if statements. So let's create some random numbers. So random nums. I will do this by using the sample function that's built into R. So I want to generate random numbers that range between 1 and 1,000, and I want to generate 50 of them. All right, so again, let's kind of ask ourselves, what are we doing here? So we actually want to find the number of random numbers in this vector that are over 500. So that should be about half of them, or half of 50, which is 25. So let's create our for loop that will kind of loop through the entire random numbers vector. So we'll type in for and hit tab to make this syntax pop up. So the variable, so a random number is just going to be a number. So for each number in this random numbers vector, we can do some work. So I want to check if the number is greater than 500. Let's print that number, as well as adding 1 to the count. So we'll do count and then count plus 1. And finally, way down here, I'm just going to type in count so we can see our final value. So let's run this entire code block, and then we can explain what happens. So you see our output here is 22. So 22 random numbers were over 500. So again, we're looping through the entire vector of random numbers, checking if the number is over 500, then we're going to do some work here, which is printing and counting, or adding 1 to the count. So if I run this a few more times, you can see our count kind of hovers around 25, which is expected. All right, so I now want to jump to creating functions. So functions in R, we've been using a lot of them. We just use some of them by using that print function. You can actually create your own. So let's create a function that prints something 10 times. So the way we create a function is by first naming it. I'm going to name it print10, then using the assignment operator. And then we use this function command, which will this is the syntax for generating a function. So in these parentheses, we need to specify what our kind of data is that we're passing into it. So in our case, we can just call it item, because we'll pass in an item to be printed 10 times. And now in these brackets, we will actually create our logic that will be performed. So let's create a for loop. And I'm going to call this I. And instead of a vector, I'm going to pass it 1 to 10. So this essentially means I is going to loop from 1 to 10, so should run 10 times. And then in that for loop, I want to print our item. So now our whatever we pass into this function should be printed 10 times. So we can run this, and we don't get too much output, but that's fine. If I were to now put print 10 and type in hello, so we're calling our function just like we would any other function. We run it, and you can see in our output, we now have printed hello 10 times. We could pass in a number as well. It would work just as well, because R handles data types for us, which is fantastic. And you can actually pass in outputs of other functions into functions. So if I were to find the mean of those weekly sales we created earlier on, the way the flow for this process is that mean, or this interior function, will be ran first. So it will first find the mean of weekly sales, and then it will then pass that value into the print10 function. So let's run this. And notice it prints 10 of the mean of weekly sales, which is great. So of course you would create functions that are a little bit more helpful than just printing 10 of something, but it is nice for demonstration. All right, up next, I do want to demonstrate that you can actually nest functions in functions you create yourself. So let's create a print 10 at position function. So again, what do I want to do with this code? I want to print 10 of a number that is at a specific position. So I will call the function command and then add my curly brackets after. So I need to think, what am I going to pass into this function? So I will pass in our list of items and whatever position I want.
Jarrod, you have 15 minutes left.
Great, thank you. I use I as my kind of like position variable because that is what I'm familiar with C++. You could just as easily call this position and everything would be fine. So we want to print 10 at a position. We can already print something 10 times, right? So let's call that function. So print 10. So now we have that print 10 function. All we need to do is pass it our items vector and the position, which is I. We use variables because we don't know what position or what items are going to be passed until we actually call this print10 position function. So we can run this to create the function. I should also mention in the upper right-hand corner, you can actually see your functions if you scroll to the bottom of your environment pane. Yeah, so that's a nice way to see some of your functions. So let's call this print10 at position function, and it's going to ask for the items and I. So items, let's pass in weekly sales again. And for position, let's get the third element, and let's print it 10 times. So if we run this, notice it prints the third element 10 times. If we check on weekly sales variable, we see that the third element is indeed 54. So when you're creating these functions, they're mainly useful when you have a chunk of code that you find yourself constantly repeating. Instead of having to copy paste it all the time, put it into a function. It will make your code much easier to read and understand, and your code will just be much more clean looking. All right, up next is going to be the apply family of functions. So let's jump back to the presentation for this. So the apply family of functions can kind of take the place of a lot of loops. So generally, if you have more experience with programming in C++ or Java, you may prefer loops. But if you are generally new to programming, you may like the apply family of functions. So what the apply family generally does is applies a function over the data that you pass into it. As you can see here, there are a lot of different apply family functions, like just regular apply, lapply, and sapply. They mainly differ in the input data type and output data type. So I made this little chart here to hopefully simplify that. So apply will take a data frame as an input or a matrix as an input, and then output a vector, list, or array. Lapply will only output a list, but we will explore that later on. But generally, the apply family will try to apply a function that we specify to the data that you will give it. So let's jump back to RStudio and let's demonstrate these in a real world scenario. So let's run our first apply function. So the way we do that is just by typing in apply. So that's the standard way you would run any function. And now it's going to ask for some parameters. It's going to ask for the data. So let's use the empty cars dataset that's built in. Next, it's going to ask for margin. So what margin means, we can give it two values, 1 or 2. So 1 means you want to apply the function based off of the rows, whereas 2 means you are going to base it off of columns. So let's actually try to sum up all of the columns in the empty cars data set. So I'll type in 2 here. And finally, it's going to ask for our function. So I want to sum everything. So I will type in the sum function. Notice you don't need any parentheses when you call that interior function. So we can run this line. And this is just a sum of each column in the empty cars dataset. Interestingly, the column sums function that is built into R uses the apply function to sum up all the functions. So if I were to pass column sums function the empty cars data, you will notice it is identical because this column sums is essentially running this piece of code. All right. So you can specify different functions here. So instead of sum, you could find max. So that will give you the max for each of these columns. And something I find pretty interesting is that you can actually specify your own function here. So we can do that by running the function command. So we'll call function and then open close parentheses. We will type in x here as that's like the element we want to address. And now we can kind of do some operations to x. So let's just keep it simple. We will just square x. So if we run this, every element in the empty cars dataset will become squared. So if we just kind of briefly look through this in the console, you notice that we get some very, very large numbers, and that means that we successfully squared all of these values. Of course, this doesn't mean much. It's just mainly for demonstration. You could actually add 2 to all of the values, but it's just whatever function you would like to specify, you can run it here. All right. So let's talk about the lapply function. So this will actually output a list of whatever your function output is. So let's pass in the empty cars data, and we can just create a, we can do a sum function. So when we run this command or this line of code, you will notice it is summing by the column, but its output is actually a list. So let's verify that. So if I type in output and assign it whatever the output of this function is, and then run class on output, we see that the output is indeed a list. So we could look at it here. It's not the best to look at in a list, but different situations will call for different output data types. So having a list output is great. All right. I also want to demonstrate that you don't just need to have a multi-dimensional data. We can actually create a cities data. So let's create some city names. So let's do Pomona because we're in Cal Poly. We can then do Chino Hills. And finally, let's do Los Angeles. Boy. So you will notice all of the capitalizations kind of weird here. That's fine. We can actually fix this by running the lapply function. So we want to pass it the cities data, and our function, let's use a toLower function. This toLower will just make everything a lowercase that is passed into it. So again, we are applying this toLower function to each individual element here. And because we're using lapply, that output will be stored in a list. So let's run this. And you can see in our console, it's a list format. And you can see each little piece of data is indeed in all lowercase, which is exactly what we wanted. All right, up next is going to be sapply. And sapply is also known as simple apply. And we can, again, run that cities demonstration. So we'll give it the cities data, and then you just need to specify the function. So let's do toLower again. Why not? So we can run this. And notice our output now has the lowercase cities. So again, we can always refer to this slide to check if check what our output data types can be. So as you're dealing with using these different apply functions, you can easily swap between them by just switching the L to an S or otherwise. So you might need to experiment a little bit if you're not getting the exact outputs you are looking for. All right, we can also do sapply with empty cars and pass it the sum function again. And we get a very, very similar output to just our standard apply. So again, they're a family of apply functions, so it kind of makes sense that they will all be relatively similar outputs and inputs. It's just going to depend mainly on the data type you are trying to pass into it. And of course, you can experiment with that. All right, finally, I want to talk about tapply, which I really like. It is very handy. So what it will actually do is apply a function and kind of group it based on levels that you specify. So here, let's pass in the empty cars data, but let's just look at MPG. And then, so this is our, first off, we're passing in our data. Now we need to specify kind of how we want to group it by. And the way we do that is just by passing in how we want to group. So I want to group it by cylinders here. And finally, we need to pass in our function. So I want to find, so what this line is saying is I want to find the mean MPG based on the, or grouped by the number of cylinders. So if I were to run this, you will notice its output here. We get number of cylinders, and we also get the mean MPG. So with this line, we can easily apply tons of different functions. We could instead ask for the max MPG per cylinder, or per number of cylinders. And here we go. We get a great little output. So you can, of course, pass in whatever data you want. Instead of miles per gallon, we could give it horsepower and look at the max horsepower by number of cylinders. So you can pass in whichever function kind of makes sense when dealing with numbers. So I want to demonstrate to you how this would kind of look in a tidyverse situation that we demonstrated last workshop. So here we have MPG, so average MPG grouped by number of cylinders. This can be accomplished in the tidyverse because, as always, there are just so many ways of doing things in R or in all programming languages, really. So there's plenty of different ways you can get the same answer. So I'm actually just going to copy and paste this. So this is incredibly similar to what we did in a previous workshop when dealing with the tidyverse. So essentially, I'm using these piping operators. So I'm first grouping by number of cylinders, and then creating the average MPG by just finding the mean of MPG. So let's actually load this all up and run it. All right, so you see the output of the piping tidyverse method. And now we can run the tapply method. And you can see the numbers, apart from rounding, that it will do to display here. These numbers are more or less identical. So it's grouped by number of cylinders, and we found the average MPG. So again, there are tons of ways to do these operations or whatever you're trying to accomplish in R. So keep that in mind when you are programming. There's not one singular approach that is going to be perfect for all methods. So experiment with different methods. We are hopefully adding to your toolbox of different ways you can program. So I want to end by talking about some of the kind of built-in functions in R that are kind of helpful when just dealing with programming. So first up is seq or sequence, which generates a regular sequence of numbers. For all of these, you can see an example input and output for the function. Sort will actually sort numbers in ascending order by default, but you can also sort them in descending by passing descending equals true. And again, you can see some sample input and output. Append is nice. It adds elements to the end of a vector. So you can see here our input vector was 4, 2, 6, 8. And we're just adding 1 and 3 at the end here, which is easy. And finally, R has all of the ubiquitous math functions you would find anywhere else on your calculator, anywhere. So R is a statistical software, so it's going to have fantastic statistical functions built in. So just keep those in mind when you are programming. So like we created that sum function. It's generally going to be best practice to not create your own function if a function already is created for you. These functions that are created by our developers, they're generally written in lower level C++, meaning that they will run faster versus your high level function that you create in R. So try to use built-in functions when possible. All right, so we can take a look at our learning outcomes again. So after taking this workshop, participants should be able to do the following: describe good coding practice, use the various types of logical operators, use for loops in conjunctions with other statements like if-else, create your own R functions, use the family of apply loop functions to simplify repeated tasks, and be familiar with some of the built-in R functions. Great, thank you very much. Please feel free to connect with me on LinkedIn as always, and please follow the social media for both AMI and the CC IDM. Thank you very much.